everyone! Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome Amanpreet Singh, the CTO and co-founder of Contextual AI. Contextual AI, the headline, build production-grade enterprise RAG applications. I think this is such an interesting company. So many super talented research scientists and engineers building this RAG optimization pipeline and just all sorts of cool things that I'm really excited to dive into. Amanpreet, thank you so much for joining the podcast.
Hi, Connor. Nice to join this podcast. Thanks for having me.
Awesome. So maybe if we could kick off kind of from the beginning. I know you had this journey from Hugging Face to contextual AI and just, kind of like the convictions that led you to where you are.
Yeah, so we started Contextual almost 2 years ago. This was just after the ChatGPT moment. As you know, like the world completely changed after ChatGPT. There was like a revolution coming, and people were just getting started with it, right? On our side, we have been in this deep learning research field for almost like 10 years now, right? So it's not new for us. For everyone else, it's like very new. But when we were at Hugging Face, we were seeing this gap after ChatGPT that people want to use AI in production, but they really can't make it to the production because of prompt engineering and other things. It will work for some of the things, but as soon as the production scenario change, it will break. You will fix the prompt again, but you end up fixing problem B, but the problem A will break. So these production systems, for like the systems in production, this was not really reliable overall. So we needed a solution that can automatically optimize over time as the behaviors and patterns change and actually take you to the production level accuracy that you need to deploy in enterprises, as well as being trustworthy, auditable, reliable. So that's what Contextual focuses on, building enterprise grade AI agents for production.
Yeah, amazing. And I know there's just so many little niche, like so many pathways of things to optimize, like the tool use or the end-to-end embedding models and just like how you evaluate these systems. So I think maybe just kind of continuing on the contextual AI story, I really had loved this RAG 2.0 branding and how I think Dawei presents it about like the current kind of retrieve and then put the input tokens in the prompt is like a Frankenstein. You're like you're like gluing, yeah. So could we maybe talk about just RAG
Yeah.
2.0?
So maybe like from the basics, because RAG has changed a lot in recent years, but from the basics, like it's retrieval augmented generation, right? You have a retriever and you have a generator, and this retriever retrieves the stuff based on your query, and then it passes down to this generator. Then whatever like in output the retriever gives, the generator has to figure out how to use it efficiently, right? So basically, in the theory, like if retriever returns garbage in, generator will throw garbage out, right? So it's very important that retriever is returning the correct information so generator can focus on giving the maximum output there. So if you think from that angle, like retriever has no signal from generator on what generator is actually getting wrong. So that's like how you do it. You do it through human feedback. You try to fix the generator through prompts. Okay, like you are getting this wrong. If you get this kind of retrieval, ignore it. But that's a very tedious process because retrieval is never learning what it can improve based on the mistakes made by generator. So in the history of deep learning, we know that joint systems who are optimized end to end work better than having disjoint systems that don't work really well together, right? So, for example, computer vision, we used to have object detection pipelines, which were very disjoint. And then they eventually moved to fully VIT based, vision transformer based pipelines. Same in NLP, like separate component for entity detection, then parsing, and so on. But they all ended up getting replaced by a single model. So, if you go from that journey, the whole point of this is like, how do you take the final feedback from the user on whether the answer or the generation was correct or not, and optimize the full system end to end in that fashion? So that's what Contextual focuses on. That's what RAG 2.0 is. Like it takes you beyond the manual prompting of the Frankenstein. It's like parts joined together to make it work, but they're not really supposed to work together. They're trained on very different kind of losses. And RAG 2.0 makes the system optimize end to end as a one system rather than being disjoint components. That's what RAG 2.0 is.
Yeah, amazing. So I guess my question then is, so I think hopefully our listeners, or I'll recommend it now if you haven't taken a look yet at things like the retro architecture or the fusion encoder. These are like examples of these neural network architectures that backpropagate gradients from the generator to the retriever. I think even the original retrieval augmented generation paper has this
Yeah.
kind of design. And, so I guess my question then is, increasingly we're using the retriever as like a tool, kind of like, so like a text SQL, like we have more query operators and just kind of like search. And so I'm curious if that perspective of like integrating a text to SQL component of it, if that kind of changes the RAG 2.0 model.
Yeah. So we recently actually went generally available. So our platform is generally available, and it has support for structured data. And the model, the pipeline we have in the platform is SOTA, state of the art on Bird SQL, which is the one of the prominent benchmarks in text to SQL space, right? So you are right. I think the paradigm has changed a lot. What we usually call the original RAG is retrieve, then read. So it's like a static pipeline, which basically doesn't really, you retrieve once and then you have to read from whatever it has retrieved. There's no option of correcting any errors, right? So I think we are way past that stage. I think recently, like the language model can decide like what it needs to retrieve and what it doesn't know in its parametric memory, and if it doesn't know the answer or is less confident and we want it to retrieve and we want it to be grounded in the document source, you want to force the model to retrieve. Once it retrieves, it sees the information back, the retrieved information, then it can decide whether it needs more information based on what it got. So it can make multiple calls to to the retrieval system, treat it as a tool, and it can also fix its errors, and it can also ignore the information that came out before just because it's more doing some reasoning on top of it. So this paradigm is called active retrieval or active tool calling, if you want to go under that particular paradigm. And this is basically prevalent everywhere, even in contextual now. So we want to rely on the knowledge of the language model to make better decisions on what to retrieve and what to actually use in generation specifically. So retro and others were still retrieve and read style paradigms. They didn't really like move beyond from that to active retrieval.
Oh, it's so cool. So I guess so I kind of have two questions in this, and one, there's like the multi-hop RAG, Baleen RAG is like the academic paper where you take the query and you write multiple queries, you have multiple searches, and then you do the the final like aggregate the search result inference. And so you might train that specialized model that writes queries only. And then I'm curious about yeah, maybe we could
Yeah,
start
so
with that.
yeah, so let's start with that. I think that's also like a good starting point, better than what retrieve and read pipeline does, because you have some reasoning component that can break down queries in a way that it's not just the original query that the user gave. There's some reasoning applied on it based on what your database supports to retrieve, right? So, but that's not enough, because in a lot of the cases, like let's take an example of like financial years in finance, right? Everybody uses their own financial years. So like there's like for example, Nvidia 2024 maps to like 2023, and there is like a lot of confusion around like if a customer is asking 2023 reports, are they talking about financial year 2024 or are they talking about financial year 2023? So based on first retrieval, you can understand like, okay, you got the reports for 2024, the financial year looks different. So if you just do single multi-hop where you just break the query into multiple queries, you will not be able to fix this error, which means you, based on the first try, you are not learning something new on the corpus, and then you're not able to retry. So there's a limit on how much it can hit. It can actually solve a lot of queries which are like A and B comparisons, but there's a lot of information you learn once you retrieve the information to see what the data actually looks like. Otherwise, you're going in blind. So that's why in reality, RAG is not just like retrieve and generate pipeline, not just like you you have to fine tune the system to also learn something about the corpus. And that's what RAG 2.0 does when it does joint end-to-end optimization. It also trains the weights to learn more about the corpus itself. So it specializes to the enterprise corpus that we are talking about. So there are ways to do it. You don't necessarily need to backprop through the whole system. You can also make a proxy of the environment that you are in, or like the, for example, the enterprise domain you are in. And then you can just use that proxy to train the model really well on that particular data. So you want the generator to see what kind of errors the retriever can make and then learn from that. And same for retriever on the other side.
Yeah, I love this idea. Like one thing we're working at Weaviate is we're trying to put like agents in the database. Where one thing we can do is the agents do this particular inference where they summarize your collection, and then you have like a prompt that's like, the artifact of our exploration of the collection. You get some kind of information about what's in there. But I think what you're saying is like you have this prior knowledge of the language model and the embedding model, and you can kind of like put what's in your database into it in this more seamless way. And yeah, it's really challenging my whole understanding of kind of like tool use and function calling. It's like external tools because yeah.
Yeah. So let's actually talk about tool use, right? Because tool use is same kind of setup, right? If you call a tool, are you able to improve your language model based on what kind of information the tool is returning? Can the language model learn how to use that tool better? Because if it can't, it will continue retrying multiple times until it gets to that particular. So there's a trade-off here, right? So you can either optimize for latency, or you can either optimize for compound, like overall like retries, which there is a chance, as you know, even though our models are becoming more and more long context, there is a chance the error will compound. So that's more risky, right? So you want to either distill it in a way that you can learn a lot about the corpus, and then you can start from there and specialize the agent for that, or you can go through a general route which will take much longer and is much error prone because the model has no idea. For example, like if as a human I throw you into contextual and we have like a lot of internal terminology, it will take you time to explore that and learn, right? So you don't know about what contextual does daily, what like for example, like in our case hill climbing means, right? That is like a very specific term in contextual, so that takes time to learn. So if the model is not learning from that, every time you do, you're starting from a cold start. So which means you have to again and again explore the environment. So going into even in test time compute, right? You can do reasoning, but are you learning something from that reasoning? Next time you do that reasoning, you can do faster. So that's still like a gap in test time compute paradigm as well, because the model weights are not really changing. So this is why in enterprise environments which are unknown or like basically non-observable environments are very hard to solve, because the model has no idea what it's going into. It has never seen that data before. It's completely new data. Like one of the examples I give is this. In one of our customers, uh, like SAT means standard acute transistor, whereas our model is hard coded to like standard aptitude test. So if you tell it like standard acute transistor, it will remember it for some time. But as you keep on going down the chat, eventually this bias or like the parametric knowledge will come up and it starts saying like standard aptitude test. So this is the kind of the problems you face. Like if you don't know this basic knowledge, how would you do further complex tasks? So this is why specialization matters for enterprises a lot, because they're sitting on a lot of in-domain data that is not available otherwise.
I love this so much. I've already learned so much about, like, I think one of the big agentic RAG selling points is about how it retrieves and then it reasons about the results, and then it retrieves some more. And that is always so heavily emphasized. But this idea that like the RAG system could be learning things, it doesn't necessarily need to just start over every time with its first search. And then this motivates me to ask you about, so we're talking about RAG 2.0, where my understanding of the vision is that you're updating the weights of the models, and then I love this. You mentioned the knowledge conflicts in the parameters, and that sounds like
Yeah.
quite. But then I'm curious how you think about like the prompt and a few shot examples. Like if we could just put this knowledge into the prompt and how that's working. Yeah.
Yeah. So actually, let's talk about it. That's a good segue to like what actually happens in production, right? So agentic RAG, basically what happens is like you see an example. So you have 5 to 10 examples as usual for a demo. You see those 5 to 10 examples, you hard code in few short prompts, and then you hope that it works. But in reality, in production, you are getting hit by like almost 10,000 queries like per minute. That's the kind of the scale you can reach if you are autonomously running in background. So a lot of users are giving feedback there. Will you be able to fit all of that in few shot if like it's failing? No, right? Like that's like you will eventually hit corpus limits as well. And we are talking about like like almost close to like 4 billion tokens of enterprise knowledge that is not there. You can't even fit that in context. So these solutions of building agentic RAG where you can hard code prompt, you can do it for demos, but it doesn't really move to production, because in production you have to journalize. You can't like hard code into prompts. And if now you have like 1,000 people giving you feedback every like hour, how would you take all those 1,000 prompts and add it to your basically prompting so that you can fix it? So in reality, this prompting is a good for demo mode, but in production, you want the model to learn automatically from the feedback it's getting. This is why we invested in KTO and so on, like so that we can learn directly from preference optimizations, like what are the preference feedback we are getting from the users. We can directly optimize the full system out of it. So it's not just also about like optimizing a generator based on the feedback. You want the full system to improve. So if let's say tool is a non-parametric tool, right? It's not really like a retriever, it's just like a function call, like something like that. You can't improve Python code, right? Like you can change it by reflection and stuff, but you let's say it's a black box, you can't improve it. But can you learn mistakes of that tool so that you can use it better next time? So that's something you can still do. So what I'm talking about is like how do we take it to production when user preferences are different for everybody, every enterprise. Otherwise, you will have a team of 100 engineers just prompt engineering it whole day, and that will not scale for the enterprises which plan to like do hundreds of use cases every time. This is why prompt engineering is good to get you to the demo state, good high overfitted accuracy on certain few short examples. But actually, when you want to move to production grade, where it's like a lot of things can happen in environment or like in like production, user behaviors change a lot, different style guides, like a lot of things change there. You need something that can automatically optimize the system.
I guess I guess for me the reason I am so interested in this kind of like you tuning the instruction is well, yeah, I think you made a super interesting case. I'm curious about like yeah, like because I think you can so I think the argument that you presented is like, hey, we have so much volume of feedback, we have like thousands of feedback, and so we can't kind of use that as a signal to tune the prompt, but can't you still do the same kind of like train test split with all this data, and you're still kind of just because you're using the LLM to change the prompt, right? The LLM's writing the new prompts, and
Yeah.
it's trying to find like this generalizable
Yeah,
instruction.
I mean, yeah, definitely you can use reflection and you can optimize the prompt. That's the first thing you should do. But generally, in our experience, like I think it hits the limits, right? Like, because there is not one kind of user just using the agent. There are multiple kind of users using the agent. So you're trying to like capture a distribution, which is very hard to capture in natural language itself. So like, how do you define a thumbs up which doesn't say anything except thumbs up or like a thumbs down? They are not giving you natural language feedback. So in some cases, we also have like an internal project where we can take natural language feedback written in text and we can change prompts based on that and change the weights based on that, but it also hits the limit. You have to at some point update the weights. So there's a limitation with prompt engineering that also sounds like I think we are assuming that prompt system prompt adherence is perfect. In reality, like it's not, right? Like if you change the system prompt, you might end up breaking some older use case that was working before. So it's not like it keeps on improving as you keep on adding more and more tasks. There is some degradation there that happens a lot of the times. So it's not like we don't use system prompt. We use system prompts a lot, and we have invested in house for better system prompt adherence on top of Llama 3.1. And so we have like better models that can adhere much better. But we rely on a mix of those things. So I'm saying like just fine tuning is not also the solution. You want to adapt the prompt as well. You want to like adapt the system as well. You have to like focus on the whole holistic system and all of the knobs that are available to you, not just fine tuning. So use everything, start with prompts, see where you can get. You will ideally end up breaking the things that were working before. Now the new ones are working, the older ones are not working. So you want to eventually get to a state where you can generalize to a domain distribution that you are targeting. So it's these things only are visible at scale, but as you probably know, like most of the AI enterprises are still stuck in like demo mode, right? So they don't see this. So we have deployed systems in production. This is why where like at scale these issues start happening, and you have to adapt the approach there.
Yeah, amazing. I think that distribution argument is super strong, and yeah, there's so many. I think there's so many directions I want to take the conversation, but I think now would be and I. So I really want to come. I definitely want to talk about you're trying to capture a distribution. You only have thumbs up, thumbs down signal, and I love ideas like Mipro or Avatar, where there's kind of like an LLM that's trying to like parse out the signal, and there's this whole like meta LLMs looking at the signal,
Yeah.
trying to say what's our gradient about to be. But I think really quickly, I know because you and the team have really like pioneered this kind of RLHF and taking it to the next level. But I think maybe before we transition to that, I'd like to talk about the LM unit and how you're testing. Just I think because it would just kind of like ground the context of thinking about optimizing. Yeah. So how do you think about LM unit and just like how you're testing the systems?
Yeah, so LMUnit actually also was like a project that started with like a need that we saw in the production or like in the enterprise setting, where like customer didn't really know like these evaluation techniques that we use as ML scientists. What they know is like, I want the style to look like this, and I want sort of like my I don't want my model to talk about China. Like if it's like global unit tests, right? Like basically as you write the Python code or like any kind of code, you write unit tests for it, and then you check like input outputs, and you make sure like it follows some of the instructions that you care about. Basically you're asserting on certain things that you care about in the output. So to allow people or like normal people to like test models and set some guardrails on it, we developed LMUnit, where you define what kind of criteria you care about, and then it will generate automatic unit tests that like the scoring model also we trained that helps you score these unit tests out of the box. So it's a binary decision whether it's passing this unit test or not. So that helps us like get to like a more granular level of detail than just equivalence, because equivalence doesn't really tell you anything. It just tells you whether two texts match or not. But going one level deeper, like does it match on the style? Is the tone same? Does it talk about is there some guidelines it's not failing for following? And like all of the guardrails, is it failing on certain guardrails? So you get like a very detailed analysis that can help you tune the prompt better or tune the model better in this case, right? So this is very useful for our customers because it gives them confidence in the system on variety of axes that they care about, and they can see, okay, my model is very good at groundedness, my model is very good at attribution, my model is really good at style following. So they get this holistic picture. Think of it like a report, right? Like a credit report of the model. So how that's how I was thinking, like this is the score you get, and this is why your score sucks, because you have like all of these problems, like, and then you get like a very detailed reports and you know where to focus on. This is how the LMUnit idea started, and that's how I expanded from there. So so LMUnit is a crucial evaluation tool in our pipeline, and it's available through platform. We also open source few components of it, like the scoring model, and people can write unit tests and can help them get out of the box. But it's more about the philosophy and the paradigm that we are trying to share with the world, that this is how you should evaluate language models.
Yeah, amazing. And I think our listeners can probably imagine how this would evolve into your perspectives on preference optimization and how you might kind of put these criteria into how you form these preferences. Really quick, I'm just curious a little further about the product of creating this Elm unit, because you may be dealing with people who want to just in natural language say I'd like a concise response, or I'd like my
Yeah.
response to have citations, and so I'm curious, like, is it like if you're thinking this is like a no code type of solution, like how involved is it for creating these tests? Like, could you just give a natural language to unit tests? Yeah.
Yeah, so same. So you can write proper unit tests if you want. You can actually specify questions you want, or you can specify a system prompt, like a global and a specific unit test style prompt, and it will generate stuff for you. So there are two ways to go about it. One is like you can write it explicitly, and a lot of the people, like financial analysts, have those criteria for their analyst reports already sitting with them, so we can use them out of the box. Otherwise, if you have like specific style guides and stuff, we can use that as a system, or think of it like a system prompt for generating unit tests. So you can specify what you want, it will generate it for you. So yeah,
Yeah.
so this is like a no code kind of solution to evaluate your models, which you can steer through natural language. So even in code, right, like when we code right now in Cursor or anything, we are steering through natural language. So that's the new paradigm. It's basically you use natural language to steer the model to do what you want. So there's no coding involved there.
Yeah, and I love the steering and how that ties with like the alignment phrasing and how you phrase these things. I guess kind of one other thing, there was this paper from Shreya Shankar is the lead author, and it was titled "Who Validates the Validators?" It's kind of like this fun idea of saying, hey, if you have LLM as judges, well, now you need to sort of evaluate your LLM as judges. Do you think it needs to go that far back, or like,
I mean, there are two axes there, right? Like one is like reliability and accuracy of the LLM. So there are papers around LLM juries that can help you evaluate it. And then there is also like how much it actually costs to like evaluate something, right? So if you are talking about production scale with 1,000 queries coming per minute, then you're actually paying similar cost to validation that would you pay for the generation. That doesn't scale, right? That's not what like enterprises want. So this is why the model that we train for LMUnit is very small model that you can run quickly, and it will give you similar to GPT-4o level results with the same paradigm, and it's very cheap, super low latency. You can use it for unit testing your code as well. So that was a goal with it. So I think you can validate the validators, but I think the question is like you are trying to fix the broken metric, which is equivalence. So why not go into like granular level of detail of like actually focusing on like specifics and like the details of what you're actually trying to capture. Are you trying to capture whether string A is equal to string B, or what do you actually care about? Enterprises care about specific axis, whether it is grounded, whether it's following my style, whether it's using attribution, whether it's not talking about like specific things. Like in for example, in certain regions of the world, you can't really talk about like compensation and all that stuff, right? Like it's very prohibited. So you want that as a guardrail of the unit test to see, make sure your model is not talking about it. And then you can use the credit report to basically say like, this is how we grade different models. So I think you can validate a validator, but I think it's more about fixing something that is already broken, and then you're trying to fix it through juries and adding more and more cost, which means it will again get stuck into demo mode because it will be very costly to deploy it in production.
yeah, I think this is, and I guess like to that point, you might say, hey, I'm just going to put these guardrail inferences like around each inference in my AI system, and then yeah, like you've slowed it down quite a bit with that. So yeah,
You can, I mean, you can also be smarter, right? You can only do it for thumbs down feedback and see what is happening, right? And generally in the history of these models, people like to thumbs down it more rather than thumbs up. So that's also like a skewed distribution, right? So that was one problem we had with KTO, that in production, you will have 90% negative feedback, 10% positive feedback. So that's already skewed. So how do we like change this to make sure like we're learning optimal policy through that, right? So those kind of questions happen there. And also, like, I think you can use the signal from LMUnit as a model to like train better reward models for your own generator and then help it optimize on the things it's failing, right? So think of it like a reward model. So in history of deep learning, or like let's say be more specific, like in NLP, verification has been easier than generation. This is why this everything works, right? Why rejection sampling works is easier to validate a plan than generating a plan. So you generate a lot of plans, then you pick one of them, and then you say, okay, this one is the best, but you basically ignored rest of the noise there. So that's why a lot of these rejection sampling techniques, which are used in R1 and others, also work, because verification historically has been easier than generation, and you basically unroll multiple trajectories and pick from that. So you can do something similar with LMUnit as well, right? Take it, you can train the model based on that. That's like deeper level of detail how you can like use LMUnit to even optimize your own systems better.
yeah, yeah, awesome. Yeah, I love that the verification is super interesting. Kind of like, yeah, I think like this kind of like MP completeness if you're really getting into it. But yeah, so I think this would transition perfectly. Yeah, I'd love to hear this story, and especially from you about like this like we had RLHF, which I understand is basically like maybe like we're even starting the story from the beginning. We have language modeling where we're predicting the next token on internet
Yeah.
scale text, and now we're generating like a whole entire summary, thumbs up, thumbs down, and then you reinforce and learning like proximal policy optimization. And so I'd love to just know like how that then evolved, and even if maybe you don't even mind just explaining that better than I just did.
Yeah, so basically, like in the history of deep learning, right? Like we started with supervised models. Like we basically were like had a train set and a test set, and we will overfit the model, or not even overfit, try to like overfit it or test train set, and then see whether like it actually generalized the test set. So then you added a concept of validation set so that you don't overfit to the test set, so you can hill climb on this particular validation set. Then we basically over time figured out like, okay, there's like this world knowledge that you can capture in the model underneath using semi-supervised learning, which is what we call pre-training through next language token, right? Like next token prediction, and that worked really well. And then, but people notice like, okay, by itself, this model is not useful. You need it to follow some instructions. This is how instruction following came into the picture, where like people created massive instruction tuning data sets, and then they supervise the model on it so that it becomes more useful, because by itself it will just start repeating whatever you are saying, so it's not very useful. So you need instruction tuning set to make it more useful. But then people realize, okay, yeah, but like instruction tuning is great, it's supervision, but it doesn't really generalize to more things that we want. And we are not like aligning with the higher level signal or the sentence level signal, whether this sentence overall makes sense or not. This is where like, because RL wasn't ready, or like we didn't have that compute scale, we can go into details of why it wasn't ready at back then. But because it wasn't ready, we had a proxy thing called RLHF, which basically tries to mimic human feedback through a reward model, which you basically kind of like train on the human feedback. So you have like multiple supervision samples. Like, okay, this sentence is thumbs up, this sentence is thumbs down. You train a model on it that the model can predict now whether this is thumbs up or down. Now you use this reward model as a proxy to generate reward for any generation that you are doing. And now you can use like normal like R algorithms to like optimize the whole system in a way that it's basically aligning with whatever the reward model has learned. So this has a lot of shortcomings because it's very hard to distill sentence level signal through reward models, like even the paragraph level signal right now. Not even paragraph, now it's an essay that it generates, right? Distilling it into like a single number, it doesn't give you any signal on what exactly went wrong. So it's like it's very surprising. It still works though. Like it's like the reward model still learns something, but you need a lot of human examples to like actually learn this through. So this is how we reach the current state, right? But the major learning in R1 was like that if you have verifiable rewards on the output specifically, like for example, math tasks and something, RL can directly work because you have verifier models which have become much smarter. Like like having a GPT-4o style model is a prerequisite even before you do R1, because it will help you verify and rejection sample the trajectories that you're generating. If you don't have that level of model, your action space becomes huge. You are like predicting in 50,000 token space, and each token you predict, you are like adding again 50,000 raised to power n, right? How would you like do RL on that space? This is why you need these models to even constrain the space down, and that's why RL started working, because now you have verifiable outputs that you can verify, and this was the lesson there. And then they mixed it with like normal data, and somehow it continued working, and they could run these experiments at scale. They could unroll a lot of trajectories, and model can unroll smart trajectories because it understands how the language works. If you start with a random model that hasn't been trained at all, it will not be able to generate any smart trajectory. So the action space will explode like we're talking about. So this is why having a GPT-4o style model is a prerequisite to even getting R1 working, because it can generate good trajectories in a world of many trajectories, and then you can rejection sample it. And that's why RL started working suddenly, because before we didn't have that quality of models. Again, same dichotomy between verification and generation that is helping us move the field forward, which I find very like interesting, because it's more like there is this imbalance. But even as a human, verification of the answer is easy than like saying like let's think step by step and then capturing everything. So this imbalance helps us continue moving forward. So I gave a very long answer, but I hope this explains like how did we ended up in RL and like RLHF, and how this the journey involved, and why the steps before were prerequisite. So what has changed is that you don't need a lot of data to train this. You have a good model, you have outputs, inputs, and you can unroll many trajectories on it. You can use rejection sampling to filter out good trajectories, and you can just supervise the model on it. Then you can do this again and again until you get a really good model that is trained well.
Yeah, it's an amazing explanation of reinforcement learning and with language. And maybe if I can interpret it like the way I see it is like, yeah, I love the way you described this like super high cardinality action space. So like, I had first learned about reinforcement learning in the like Q learning setting where the model is trying to predict the expected reward for some state action combination. And so if you have 50,000 actions, like all the tokens, but then I think about it because the language model it creates this prior on the languages, and I think the prior is kind of what makes the like state the like action value estimation tractable like that.
Yeah, yeah. Otherwise, it's intractable. A random model, you can't start from that. So the most surprising result from R1 paper was like the R0 model, R10 model. This paper, this model, you can directly start from a language model. Not don't even need to do SFT. You can just get to R1. So SFT or like the supervised fine tuning is only needed because you want it to make it human interpretable or be able to make the humans able to use these models. If you don't have that requirement, you can directly jump to RL. So that's kind of like a very revealing understanding from that paper. And we knew from past as well that if you directly do RLHF with KTO and DPO, you can sometimes skip SFT step because it will learn based on the instructions you are giving, like how to follow those instructions. So I think having that validated is very, I think, very beneficial for the community.
Yeah, amazing. So then I guess my next question would be, so is my understanding correct that like with these preference optimizations, like anchor preference optimization, and so these are like innovations on the reward model part, like the signal that you
Yeah,
then, yeah,
yeah,
so
mostly on that part.
yeah, so maybe if we could dive into that, because I think the reward model probably, I imagine like enterprise RAG, you're probably able to get a solid data set of feedback, but I mean maybe it's very interesting to kind of think about like how to self supervise this feedback, or maybe if you're just comparing two systems to each other, and that's where you get your feedback, like RAGs.
Yeah. So basically, is like generally with like most of the algorithms, you need paired data. Like if this is a bad sample, what is a good sample? And there is like a in APO basically we capture this gap between bad samples and good samples, and it's depending on like what kind of data set you're using, that gap can be different. So we call this like anchor gap, right? So you want to normalize this or like have samples which make more consistently sense. So that's what the APO paper is mostly focused on. But if you take a step back from that, like KTO is focusing on not using preference pairs and just focus on like the direct preference. It's more like you have the feedback directly and you can optimize on it. You don't need pairs. So it basically it changes the equation a little bit in a way that you don't need to like have both sides of the pairs. You only need thumbs up or thumbs down. It doesn't need the pair thing. This is very important in production because in production you're not going to get annotated pair data, right? So you're just going to get the thumbs down, and then you can send it to your annotator and get it annotated, but that will not scale. So this is why it's important to focus on these algorithms because this is what it makes it work in production. But okay, so what it does it mean? So now you have a trajectory. Like in agents world, we just call the whole thing trajectory, right? So, but in this case, it can be as simple as a retrieval, generation, and then the feedback, right? So it's a triplet in that particular case. Actually, it's a quadruplet because it also has a query associated with it. So you can use this information to train a model on it, or like let's say train a trajectory generator on it, and you can generate more things like that. So it's important what this part is, this trajectory generator. How do you train it? So now you basically you have examples of what these good trajectories look like, what these bad trajectories look like, and you can generate many more like that. So you basically can use those trajectory to optimize the whole system then. So that's how I would think about it. Basically, like how do you at the end of the day, the question is like how do you map to the distribution that you are trying to target, and how do you generate data similar to that distribution? And that's what most techniques like rejection sampling help you there, because you're generating a lot of data similar to the distribution, and then you're verifying which data is actually similar to the distribution, and then you can use that data to like have like a better quality set that you can train on. So you can just fix the fix a model's problems by generating a lot of data and then seeing which one didn't make sense, and then keep on constraining it into that space that makes sense. And this is why specialization becomes important, because in enterprises, it will make a lot of mistakes in the enterprise data. But can you learn from those mistakes? And if it is completely wrong, can you learn from that bad trajectories as well? So beyond that, it's more about the secret source of contextual, like how exactly it works in practice, like how do we like do data distribution matching and few other things, you know.
Yeah, awesome. Well, thank you for that. I have a much better understanding of, of RL and this alignment after that. Yeah, so I guess like it sounds to me like well, I think everyone would love to have a real world data set if they can achieve it. I love synthetic data and synthetic training and testing data, but I guess like if we could talk about this kind of specialization and maybe just the role that real world data has, like if, contextual AI that coming in, uh, you have like a legal team that you're helping with their chatbot or whatever their RAG system is doing, whether it's writing a report. I don't want to limit us to chatbots, but like whatever. But like how does how this specialization, this real world distribution, how impactful is that?
So basically, I guess how it starts is like you can go two ways, right? You can work with a customer, figure out what they want, like have generate an eval set through either synthetically or through humans and get them validated by them, right? And the other way is like you can put the more agent into production and have them use it, and you get some feedback, and then you can use that to unroll the specialization part. So the point is like more they use it, more feedback it will generate, better it will keep on getting over time. So it's not like fully online optimization, but it's more about like how do you take this data and then you generate more data based on it, and then you basically train the system on it. So it's like this end-to-end RAG 2.0 optimization as well. So the data is proxy to whatever enterprises are providing us. You can also like do other things, like so legal case you came in, you have a use case description, like what are you trying to do, and then you can basically using the description you can still make a lot of good guesses on the data they have like uploaded. So you still have the data, right, that they uploaded, so you can say like, okay, like based on this data these kind of questions would probably make sense. So like this so you can do all of this automatically as well, so you can avoid that cold start problem as well. So what matters over time is like this data understanding that you collect about a particular enterprise domain, and that helps you move faster. And that's why contextual in certain domains knows way more about than any other company. Like what do they care about at the end of the day? And this is more important for like bigger enterprises who are like very protective of their data, like they don't really know anything there. So this is how the specialization part will work. You will come in, you will use it, and then the platform or the agent will keep on improving with time.
So then I want to take your temperature on this idea where you give it you give it the corpus and then you automatically generate let's say it's question answering, and so you're automatically generating the questions, or maybe even it is that chatbot and you're kind of automatically generating theoretical multi-turn conversations. And so do you
Yeah,
think like, yeah,
go ahead,
it's
go ahead.
like perhaps it's like the information is so specific that you can't even like have a synthetic question written because it, yeah.
Yeah, I think you are hitting to the actual problems that will happen in production. The data is so specific that you basically uh, can't even generate a proper query from it because the model has no idea about it, right? So this can happen, like I told the example of SAT, right? So this can happen continuously. And but I think the thing about this is like that's the case, the user will still be giving you feedback and asking the questions to the agent, right? So you get some sense of what the query distribution would look like. So you can use that as a proxy for the query distribution as well. Again, you can use this sort of like imbalance between verification and actually generation. So you can generate a lot of queries which might not make sense, then you can verify whether this query would make sense or not, right? So that imbalance will help AI continue moving forward and forward. So I think there are various ways to get that proxy signal, and you can get it to the customer. You can do more things on verification side, and you can do a mix of things. So depending on like what exactly the use case it will look different, but this is why we have a platform that can handle all of these things.
Yeah, yeah, I think that's so cool. Yeah, it makes me think that this, yeah, like the human in the loop in this sort of like LLM as optimizer, trying to come up with these proxy questions based on what I've seen so far, and I'm optimizing myself over here. All that sounds really amazing.
Yeah.
Uh,
Basically, I'm trying to like match the distribution of what the user would care about in this particular domain. And this is why like even deploying like an RL tuning algorithm, and OpenAI has released a fine tuning RL fine tuning API. They are basically trying to see whether in like unknown data how this fine tuning mechanism works. Can they unroll good trajectories there? Can they tune the model there? So you don't need a lot of samples, right? You can start with 16 samples. You can generate 16,000 trajectories from them. That's different ways of reaching the same answer, but you're exploring the space fully, like calling different tools, calling different like retrievers, calling maybe Python functions, calling operator or web browser, like all of that stuff. You mix it out. You can introduce temperature to introduce some variance, and then you basically are generating a lot of trajectories that gives you like understanding of the space you are working in, what tools work in what case, what tools didn't work in what case. So you can generate a lot of trajectories, and that gives you like a lot of information about that particular moment. So you don't need that much of supervised data. So this is why I think in the future, as we move forward, fine tuning will become more sample efficient, and like super specialization will become more sample efficient. So you can give like six users 16 to 20 times, and it already learns what you want.
Yes, it's amazing. And I guess I want to like this is kind of mechanistic interpretability. That's one of these like kind of emerging research topics. I'm curious if you like earlier we were discussing like parametric knowledge conflicts. Like what was it?
Yeah,
Ethnicity? Yeah, and yeah.
yeah.
Is that
So we invested in this as well because for our customers, it's very important that they can audit the model, they can understand whether it's reliable or not, and the model should be able to tell them when to escalate to a human as needed. So in our platform, we have this uncertainty feature, which is basically tells you how uncertain the model is, and you can basically decide some threshold, and based on that, you can decide, okay, if this is this much uncertain, then I should escalate to human, right? And the other way is like we provide audit trails, complete audit trails of where the data is coming from, how it was grounded, proper citations. So think of like perplexity style, but for specifically for enterprise, where like you can go back to exact data this particular claim came from. So this audit trail helps like enterprises maintain a record of why this particular agent made this decision, which documentation it came from. Then there is second level of detail, right? Like how do you resolve conflicts in documentation itself? So the so for those kind of cases, you want to learn from user preferences of what kind of data they want. Like basic preference is recency, right? You probably want to have more recent content and you want to resolve it based on that. Then there are like also preferences, right? Like some companies say, oh, I prefer my internal docs more than the web search docs, right? I prefer, for example, uh, let's say like Nvidia stock over some other stock. I prefer this analyst over some other analyst. So you can specify all those preferences and steer the model to like resolve those conflicts in this way, and that's how you will resolve those conflicts in a way. So there are like various ways to do this, and you want to make sure parametric knowledge is interacting well with the retrieved knowledge in a way that it's maximally beneficial for the user. So that's how we think about it. And you don't want to like completely kill the parametric knowledge, because otherwise the model is just like repeating shell of like knowledge that came in. So you want the model to reason about stuff, right? So this is very fine grained knob that you have to control there. This is why we still train our groundedness models and conflict resolution models in house, because we want that finer grained control.
yeah? Well, it's such a compelling vision. I don't know too much about the technical research of that to really keep that topic going, but yeah, it sounds awesome and such an interesting idea of this parametric knowledge conflicts and how you resolve it. So I get one other question I want to ask you about from when I first heard about RAG 2.0, and I just think about this whole idea is kind of like where you draw the line between like discrete black box optimization problems and then continuous optimization problems, and particularly say, so we can treat this embedding generation as totally end to end, but your embedding model might not be performing well because your chunks are too small. Like you have 100-word
Yeah.
chunks instead of 300-word chunks, and so this discrete parameter of the chunk size that could be something that could improve the end to end performance. Yeah.
Yeah, so I think generally you can go back and optimize as early as you want into the pipeline. Like basically you can focus on resolving extraction issues. So how it will work in practice is that you can train like different kind of signals like based on this extraction output. Like I got this answer. How does this changing this extraction output fix my answer? So you can do those kind of A/B tests, and you can get a lot of signal which you can use to improve extraction as well. Same goes on the chunk size. You can try different kind of chunking strategies. So you have to explore the space, right? This is the thing. Like you have to explore the space, and you can try different chunking strategies and see like how it impacted the generation, and then you can just say, okay, like this is the optimal generation parameter. But it all depends on how big the space is. So if your chunk space is like very big, you will not be able to run this at all. So this is the challenge that we also face in HD, and we had like a technique to overcome it. But this is a real challenge. Like if your space is huge, for example, even in retrieval, right, you can change the query a little bit, change the top k a little bit, then you keep on ending up with the exploding permutations of things, and then you will not get anywhere. So this is why again it's very important to match the distribution and then figure out how you can generate samples like that distribution and do better there. So this is why the chunk size parameter I think is a little bit harder one to resolve, because you want to make sure the size, the chunk, the options are limited, but you're also not like exploring the space fully. So this is like a classical problem in RL, right, where you like shrink the action space and make sure like it's still working. So this is why I think you can optimize black boxes in contextual. Like you can even put Claude and you can optimize it. But the kind of things you can do are limited, because with prompting, you can only do so much. And then we were discussing earlier, like sometimes a system prompt adherence doesn't really work. And then for re-ranker, if you want to change something, do you have some instruction following control that you can change for re-ranker, right? So those things matter. And if you don't have all of this, is parameter, you can just optimize the parameter so it gives you more power at the end of the day. So more you handicap the system by not showing it stuff, weaker it will be. But more you give control, better it will be. So you want the AI to figure out what to do, not us in general, like how to optimize itself.
Yeah, I think that's super. I guess maybe like one aspect of it I might push back is like if I make it so we're talking about like re-ranking, and I might want to have you boost search results that are like yeah, by recency. And it's like if I instead put this into my database system, like my BM25 engine, or like like I have like a ranking expression, it's like I can kind of like scale that better than if I'm going to try to make it end to end. Do you think that's a valid
Yeah.
point? Like,
So I mean, you are empirically limited by the performance of the component itself. So if you can't change its weight, then for example, this is very important for tool calling, right? If you can't change the tool to perform better, then you are limited by what tool provides. So there's a good example here. So Notion search, for example, Notion search, you can't, in the API, you can't actually use content of Notion pages. You can only use title. So now you're already limited by the get-go because you can only use title. So there's so much you can do, but you can optimize the model to figure out what a title would be for like something like this query. Which is why I'm saying if you use BM25, you're of course limited by the BM25 limitations, but you can do best thing for that BM25 tool. So you should of course improve your components also, but like it's if you, in the end, if you make everything parametric, it can learn itself. If it's not parametric, then you have to basically like be patient, or like be more reasonable with whatever is provided. This is why adding components like re-ranker help, because they are basically, I think the better way to think about it is like they're making your problem easier by doing some heavy lifting by itself. So you're already introducing constraints into the system that will help you do the job better. So more constrained the system is, better easier it is to optimize it. And then you remove constraint, it becomes more general and general and general. This is the history of deep learning as well. Like constraints keep on getting removed over time. But to make the research work initially, we added a lot of constraints in the model. Like supervised tuning is more constrained than like semi-supervised training. So on, like RLHF is more constrained than RL itself, because you're not exploring the full space. You're just exploring what humans are providing, trying to proxy it. RL is more unconstrained. You're exploring the full space. Something might come after rejection sampling as well that will help us move even faster.
Well, it's all been so amazing. Amanpreet. It's such a great exploration in all these like kind of releases from contextual AI and some of these things that I want to kind of pry apart more to learn more about. I kind of an anchoring podcast question I like to ask people is just sort of like like generally what future directions for AI right now are exciting you the most.
So I am very excited about specialization using RL specifically. I think we had like two tenets or like two axes or two mottos that we started when we started contextual. We started with this: is one is system over models. We strongly believe that single model will not be able to serve the full system. Like we have talked about re-ranker and stuff, right? You need a system to solve actual problems. Like one model doing something, other model doing something, other model doing, like they're working in conjunction with each other, and then they improve together. Second is specialization for AGI, specifically for enterprises. So we strongly believe that specialization is needed because even a general agent, it has to learn if it goes into the enterprises. And we know test time compute is not teaching anything to the model. So it might in the future test time compute will start updating the models, then you are training it back again. Right? But like how do you like compress this into like something that is actually deployable? This is why specialization is an important access for us. And I this has been improved time to time. Like OpenAI is working on their own fine tuning mechanism, like API. Everybody's releasing a fine tuning API. So they are also seeing the limits of these general agents in like unknown environments like enterprises. So I'm very excited about this specialization axis. And of course, I think the foundation models will keep on improving. DeepSeek Carbon came out, but didn't release many details of the training. The model is there, but like the three-step pipeline is like we don't really know what they did there. They didn't share any data. So I'm very excited about this continued pursuit in open source and how agents keep on becoming more like humans, right? Operator and deep research, they're more human-like. They're using browser like us. So they're proxying actions that we will take. So they will start doing stuff we are taking. Maybe like 10 years, like maybe 5 years from now, agents are doing these podcasts instead of us.
Our last podcast with Karen Gohl from Cartesia AI, who's already trying to replace my podcast with a text to speech model. I've got an agent.
Like there is a Aman agent and there is a corner agent talking to each other, trained on our thoughts, right?
Yeah, awesome. Well, Amanpreet, thank you so much for joining the Weaviate podcast. It's amazing coverage of all these topics. And I'm so excited about the future of the partnership between Weaviate and Contextual AI and just, continuing to see how
Definitely.
all this cool stuff evolves. Thank you so much.
Yeah, really enjoyed this chat. Thank you for having me. Take care. Bye bye.